So here's two more problems, and I just want to talk about the strategy, things you might try. What is this problem telling you? And the first one here, the integral from 1 to 3 of r to the 4th times the natural log of r, dr. I put that times in red because I hope that's a hint to you that this one is probably what? Integration by parts. Integration by parts. And I said probably, and it is integration by parts, but I said probably because at this stage, you're probably kind of guessing. I think this one is this technique. I think the next one is some other technique. And I'm looking at the second one right here that I've written. The integral of t over t to the 4th plus 2 dt. And is it u substitution? No. At least not the way it's written, right? I could rewrite this one as the integral of t over t squared plus 2 dt. And then I'm going to think about what I've said. Think of the numerator and the denominator separately. So I'm going to put 1 over the denominator. I'm going to put the t next to dt. And then I'm looking at it and I'm thinking, is it u substitution? Yes. So u would be t squared. And what's the derivative of u? 2t dt. So du over 2 is t dt. And this is going to give me, at this point, the integral of 1 over u squared plus 2. Here, all of this was u. I still had that square on the outside. And then t dt is du over 2. So that's 1/2 times the integral of 1 over u squared plus 2 du. Now, what is this problem saying at this point? Inverse trig function. But it's not a really straightforward inverse trig function at this point. But when I see 1 over the variable squared plus a constant, usually that would be a 1 for an inverse tangent function. That's what it is, inverse tangent. But that's a 2 right there, so I probably have to address that 2. But it is an inverse tangent when I keep working with it and simplifying it. Okay.